Hey fifth graders, here is your lesson on volcanoes. So this is the lesson after your plate tectonics one, and they two tie really closely together, and you will soon see why. So as we go through this lesson video, you can be starting to fill out your guided notes if you would like at this time, the ones that look like this, that say volcanoes at the top. If you want to wait for the guided notes video, that's fine as well too. So go ahead and let's get started. All right. So what is a volcano? Let's start with the definition here. So a volcano is a mountain that extends down to a pool of magma between the crust and the mantle. So in our last video, we talked about the kind of setup of our Earth and where the crust is. And remember, like a pizza, that's the outermost layer. And then we also have that inner, the next layer down, which is the mantle, which is kind of the liquid magma of our Earth. Now, a volcano expels magma, so it's called lava once it hits the surface. So anytime it's underground, it's magma. Once it hits the surface, it's lava. So here's a little cross-section of a volcano. So we've got the different layers of our volcano, the magma chamber. Now it's going to have one main vent, and sometimes we'll have secondary vents or a secondary cone, and we'll have layers of ash and lava that cool and harden over time to kind of make the mountain even bigger. Oh, sorry, went on too far. All right, so underneath your definition, you do have different types of volcanoes. Now, not all of them are on here. Oops, sorry, I'm trying to find where I fit. There we go. So with your types of volcanoes, the first one is your composite volcano. This is what I call kind of the movie style volcano. So it's going to have large cinders, lots of lava, and they're really big. So you're going to have the cinders are kind of dried lava and ash in between where the hot magma is flowing. It's going to have one main vent here. The one I like, though, is my favorite, is the cinder cone volcano. So it doesn't have any of these kind of side vents. It just has the one main vent. It's really small. It's kind of steep sides. It's going to have a similar shape to the composite, but a lot smaller. Now the shield volcano is going to be the biggest kind of volcano. These are what the Hawaiian Islands are made up of. So it's going to have like lower slopes. So remember we talked about slope, it's the steepness of something. So it's going to have lower slopes on this one. Inside too, it has frozen lava, which is kind of cool. So that lava cools and hardens, and that's what makes the shield volcano so big. Some other types of volcanoes that are a little bit different is the giant caldera volcano. And the reason why I like to include this one is because it doesn't really even look like a volcano. So what happens is that we have our magma chamber underneath, and then there's like kind of this circle depression on top of the volcano, but it's actually really flat. It's going to have large faults or fractures, kind of cracks in the ground, and then magma can end up seeping up those cracks and actually kind of oozing out. This is what Yellowstone is sitting upon, which is kind of crazy to think about as well. And the last one is a fissure volcano. And again, this one has really low and flat. There is no central crater even on this one. It's just going to have large lava pools on a nice flat plain, and lava is going to kind of ooze and spew out of the cracks. Now, what do volcanoes and plate tectonics have in common? Well, just about everything. So, as you heard in the plate tectonics video, a lot of those interactions, especially at the diverging plates, the pulling apart, can cause the magma to ooze to the surface. Same thing with those subducting plates, the one where one goes under the other. We can start to see the magma getting heated and needing to be released. So there is actually a real place called the Ring of Fire, and this is all around the Pacific Ocean, and that's just because this is where the plates are meeting and they're having those really volatile reactions, those really harsh reactions. And so especially like along here, along the South American plate, they have those subducting plates causing lots of volcanic activity. You might not think of Alaska as being volcanically active, but it is, just a little bit cooler now. But yeah, so the Ring of Fire is because there are lots of volcanic activity all along these edges of these plates where these plates meet together. Now, there are three things that form volcanoes. These three things that form volcanoes. One of them is those subducting plates. So again, when one plate slides underneath the other one, it's going to dry out, it's going to melt, and then it's going to rise. Because remember, hot things rise, and so it's going to rise to the surface and erupt. The next one, it's It's going to be those diverging plates, those pulling apart. Remember, as it pulls apart, the magma fills the spot, and then it's going to cool and create new oceanic crust. Now the last one is one we haven't talked about yet, and this is a hot spot. Now a hot spot is not along a plate boundary. It's going to be right in the middle of a tectonic plate, and it's just one spot that is really volcanically active. So we'll get more into that in just a minute. Now, with your convection in the mantle, so remember these hot mantle convection cells, they kind of act like a boiler under here, heating the magma. Then once it hits the surface, it starts to cool and drag it down. So here we see a subducting zone, whereas it gets getting pulled underneath, it starts to heat and dry out, and then release as magma and lava. The diverging plates here, remember they pull apart, it's rising to fill a spot. So those are two of the three. Now the last one is this hot spot. Now hot mantle plumes, they break the surface in the middle of a tectonic plate, which is rare. We don't see those a lot. But Hawaii is in the middle of the Ring of Fire, and it was active for a really, really, really long time. So what happens is we have this hot mantle plume, and this stays in the same spot, but the crust is going to move. So as we see this hot mantle plume rise and rise and rise, remember this is the stationary one. It's going to stay in the same, it's going to stay in the same spot. Now, as it stays in the same spot, it is going to, I'm trying to find a place where I'm not in the way. There we go. It's going to heat that crust and cause an active volcano. But we know that this crust is sliding. So it's going to make a volcano and then it's going to slide over. It's going to make a new volcano and it's going to slide over. But then we see the islands getting smaller and smaller and smaller to the point where they're even underneath. Now, those new islands are going to form in a line. Just like if you've seen Hawaii, they're kind of in a curved line. Going from biggest is the newest one to the smallest one, which is the oldest one. And this is because of erosion. Okay, so those volcano islands are going to erode over time. So the newest ones are actually the biggest ones. Now remember, your ocean crust moves super, 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 super slow. So that's why it has the time to actually form an island before moving onwards. All right. Now we have three different terms. We have active, we have dormant, and we have extinct. Active means it's currently erupting, like watch out, it's currently erupting. Dormant means it's not erupting right now, but it is supposed to erupt again. This is what a lot of volcanoes fall under, is this category here. Now lastly is extinct. This one has not erupted in 10,000 plus years and it's not supposed to again. It's kind of dried out. Now you can tell the difference here because we've seen some green growing on here. This definitely looks a lot more weathered away, a lot more eroded away than this one over here. Now, what happens during an eruption? What happens is pressure starts to build up underneath. Remember, in this hot volcano, magma gets really hot. And so this magma then is forced through the chamber, which is its skinnier area. And then it's going to erupt. It's going to explode. And the type of explosion that happens kind of depends on two things. How much gas there is, like the amount of steam, and then how much silica there is. And this is what causes the lava to either be really sticky or really more like water, kind of easily flowy. So that's when that magma hits the surface, it becomes lava. Now I'm going to put this link to this video also in the assignment, so I'd like you to watch that. It's pretty short, but it does a really good job of talking about different kinds of eruptions. So after the eruption, you're supposed to write 2 to 3 sentences, so this one's kind of up to you. Now, there's going to be ash in the air. It's going to be really hard to breathe. It could be really bad for your health. It could cause mudslides and earthquakes. Obviously, lots of erosion is happening, lots of loss of plants and trees. It can even destroy homes. It could even kill people, loss of life if people don't get out of the area in time. And it can even disrupt air travel as well. There was a volcano over Iceland that actually grounded planes for a couple of months because it was so bad. So here we have a photo of before the eruption and then after the eruption. So we can see how much erosion happened between the mountains. It literally blew its top. So kind of crazy to see the differences between those two photos. Here is another one. This one was out in Washington. And so what we see here, excuse me, sorry, is we see nice snowy top, huge tall pine trees, and a little lake here, but after the eruption. Huge difference here. All of the trees got pushed down. This lake became really big, big differences between those ones. Now, I'll post these two more just like a for fun one. I'll actually just this underwater volcano one I think I'll post. This one's a little bit longer, so I probably won't post that one. Now, you're done with your notes for the video, or excuse me, for your guided notes sheet, but I do want to talk quickly about earthquakes because they're kind of along the same scale here. So earthquakes are sudden and violent shaking of the ground as the result of the moving of the Earth's crust or volcanic activity. So volcanoes can trigger earthquakes as well as tectonic plates. So here we've got the same street before and after, right? So you can see this clock tower is the same and this building's the same, but not much else is. So the causes, there are a couple different causes, but really when two plates rub together, this is a sudden release of energy. So like we talked about in the tectonic plates video, as they're transforming boundaries and they're scraping, sometimes it gets stuck. And the pressure builds and builds and builds and builds and releases really fast. And this is what causes those earthquakes. So underground, where the center is called the focus. If you watch the news, though, they might refer to the epicenter, and that's just where the center is at the surface. And then it sends out these waves. And so scientists do a lot of studying of waves through earthquakes. Another way that they can be caused is because of volcanoes. The movement of magma can exert pressure on a rock until it cracks, and then it causes that earthquake as well. These ones aren't typically as strong as the other ones, but it can cause some kind of side earthquakes. So as they're scraping, remember, as they're subducting, it's not friendly. It's scraping in, it can cause those rocks to crack as well. All right, the land after the earthquake can even trigger a tsunami, especially if this happens underwater. So a tsunami is waves measuring up to 80 feet high, moves at over 300 miles per hour, super, super dangerous. What can happen is they can create large fissures in the ground, which means large cracks like this. They can lead to gorges and valleys, and here you can see how the waves moved through the railroad here, created those waves. All right, looks like that is it for the volcanoes lesson, so I will post the video for the guided notes. Please watch that and get your notes done. Thank you.